Welcome to Driven by Me, and this is I don't have any voice. Yeah, I've been walking all day long, so when I'm getting tired, like losing my voice. Okay, oh, I needed a break. I needed this break because if I work too much on it, I might end up getting tired. So sometimes I need breaks. But I did work on. I did want that to solve the PCG loop, which I did solve. So I will check this out today. Maybe faster than faster that as fast as I can, so that go back to the character. Maybe we'll see. So this is my sponsor on the other corner, 50% off on the factor meals. So the coupon code is only for US citizen. And what else? What else? I solved it. I finally solved the PCG feedback loop. Let's take a look. Okay. It was a bit complicated, but as we will see, I will explain everything because now I worked in the background. It's been I think it's been 3 or 4 episodes just trying to make this work, trying to understand PCG loops, and finally, I still don't understand, but I did it. A bit odd. I'm going to open the fan. There you go. There we go. Where's my music? Is the fan is not blowing on the microphone? The music is not loud. Or is it? Okay. Okay. PCG default. Well, let's take a look at this. And also, I forgot to bring this. Just open the map level. There you go. There. It's beautiful. Of course, the offset is not yet done. That would be with other stuff, like the floor should be inside. So when I will have to do something that here that remove the floor. If I will see, because if this is a bit way back, successfully removed some mesh. I will do. I think my fan is blowing on the microphone, but it doesn't show on the output. So if this goes back inside the house and this back, it will overlap. So I can do purge, self pruning, self pruning, so that it removes both. And then if this is offset with the offset of the one below, same thing. And this what it would do is that the higher we get, the more pruning is occurring, which at some point some roof might disappear if the house is too small. But that's what I will have to do in the next episode. Okay. So default building. I forgot something. It's this one. Made by so I'm building upon why are you here? Forget about it. Forget about this. It's oh no, it's there. I don't have it. I don't. So this is the result. How clean is it? It was a real mess when this morning I did a cleanup. Real mess. Everything that I use, trying find how to make this work. There was a lot of, if you remember, and now it's all clean. I will need to integrate those inside this new stuff. Well, for the people who are new, because now I named this video feedback loop, so that it might catch some new people trying to find about feedback loop in PCG, and just to iterate for them if they are new. I'm doing a tutorial. I'm building upon a tutorial I found on YouTube, which is, let me open my browser. Down there. This is safe for work browser. Safe for Steam browser. Don't type. So procedural in mind. Okay. Procedural in mind. Procedural minds, but my mouth was faster than thoughts. So you go on these playlists and you get is one of the best, if not the best, for PCG in Unreal. So it's a building series, but it's not this one. I think this is the old. This is the 5.4, and there's another one. I think 5.5 something, or else it's the old. This is the new one. Anyway, I'm building upon
actor
one of those. Either this one.
So plug in
Oh
the
yeah,
PCG.
yeah. This is Fido. Okay. Yeah, the old one has more stuff in it. Like the furniture, I will go over it. So I'm building upon this one, which is the same as this one, but in Unreal 5.4. Yeah, in this series there is less. There is no.
The height of them.
There is no furniture, but it's very compatible. There's a few new things in it that he shows up, but I think you can still do the furniture. I will probably. So I'm building upon this one, and now let's go into the meat of the matter. I don't know if it's a real expression. I just said anything that came to my mind. Let's get in. Okay. One issue, it's not an issue, but it helped me. If you remember last episode, who have seen it, I made. I did the logic that is in both of those two were mixed inside the same loop, which was harder to deal with. Also, first thing first, just to anyone who's making the same kind of stuff, no, I duplicated this. I didn't play with. In the last episode, I tried to modify this, but I think this way is better now. I just made a double, which is a roof story. Yeah, in the tutorial, he calls this only wall loop, I think. I duplicated and I just changed the number of a story. That way, if I kept this one, I would need to have the same amount of wall stories as roof stories. But now they are decoupled. I can have a different amount of roof story than wall story. Okay. Okay. So now the transform is just lifting up everything. As you can see in Z, it lifts up everything at the height of all walls. As you see, the number of stories multiplied by the height of a wall, it brings the roof on top of all walls. This is the creation of the mesh. Or mesh, not the mesh really, but if we look at the wall points there, it creates the point. Let's see how they look before. Just sometime, it's been so long since I've been there that I forgot what it was. But I know that this is needed. What it does, let's look. Okay, it's the pattern to make walls, which just I'm just going to take a look at it just so I remember. This is made by procedural in mind, like pretty sure, yes. I call it center pivot, pivot. French is pivot. English, I'm not sure. Same thing in French. Pivot, pivot,
pivot,
pivot, pivot, pivot, pivot. Okay, pivot. So I will remove the other one because I have another one which is corner pivot. But now I do like because when you do modular building, not procedural, you like the pivot to be on the corner. That way, it's easier to place and place the next one next to it and extra. But when it's not that, it's harder or easier. It's just that a lot of mesh sometimes have it in center. So I've just made both of them, and I've decided to stick with the center. If I have to modify the pivot, I will put them all in the center. So this is just like we can check. Oh, I forgot to test the chat. The music has some kind of voice. I thought it was the PCS. The driven mind is also said this. Okay. So let's see. You can look at the input, which is here. And to do that, you go in spline point input. This is what is inputted. And it seems to only move them. You can see it's index 0. It will move them if I look at the output. Moves them. And I think it if I remove this, that it's to do alt click and bring this. As you can see, it's the pattern for the contour. It rotates them. If I don't do this, it will be just side by side. And the rotation is done inside this one. I made it procedural. Mine didn't do that. This I collapsed them into a function because that way it was easy, and I reused it elsewhere. But there it rotates them around the spline. This okay. This is just that, just so new people know a bit more. Before end. Then I did this. This is what I did to solve it. I separated the scale mesh side that procedural mine does. The difference is that procedural in mine, procedural mines have it outside the loop, outside, like you use it outside here. Dash scale data point in. Want to check what is going to out. Oh, it's grayed out because something. See, well, sorry, loop mesh. What's in? What gets into it is all the points of sorry loops. So it seems to be all the. If you count 1, 2, 3, 6, 12, and 12. There are 12 mesh around the spline. And it's those 12 mesh. And there are the I wonder what it is. Why it's just 2? Why just 2? I don't know. Wands. I think it's because there are just 2 of different kind there. But very highly probably that is the reason. But me, the thing is that if I could look at my input, they are all what the F. I could have done it outside maybe. I don't remember. Oh, I need the size because they have different size and height and depth. I adapt to each story with the size, everything else. So this I separate this logic from the feedback loop logic, so that way it has been way easier for me to solve this. So if we look at it, just resize them to their to a pre-recorded size. This is not necessary anymore. This is not needed. Why do I get the height here? I don't think it's necessary. I would need to check this one. I don't think it's necessary. I'm not sure about it. Okay. Because I don't need to hear the previous index mesh height. I really don't need it. Why previous? Oh. It seems it was so back a couple days ago that I don't remember that, because once I isolated this part, it became a bit easier. And if we get the input, what it did is just to resize the mesh correctly. If I want to put another size to each mesh, I can in the blueprint. That's the use of this one. It's not so much of our concern for what's coming up next, which is the feedback loop here. So I take the meshes that are here, saved in the blueprint, and from the blueprint in here, and I do a loop of each of them. And if we look at the output here, I skip the first one because it doesn't need, it's at 0, so it doesn't need an information about the where to put it. 0 doesn't need more than that. Skip here the first, sorry. You go to the second. And it's here, like if it's equal, if the loop index is equal 0, skip it, and the rest do the rest. So it does the rest. It search for the index here. Attribute partition will split them. So you see the. Do I need it? Oh yeah. One thing I did before that, is it there? The output is. I think it's in there. Yeah. This one. I should rename it. Because what it does is, if we look at the side of them, it takes only the mesh that are below. So here I get all the meshes in the mesh loop, and I spread them. I take all the meshes that comes from the blueprint, and I loop over them. Mesh loop. And if you look at this is the output I want. Input, mesh loop. There are 5. It's 1, 2, 3, 4, 5 with the little roof up. If I go input here, no, mesh loop 5, 5. So I multiply on each, all the 5 here. I put them into 0 to 5 index, so that way I can calculate. I can remove the first here, the 0, and I can tell, okay, if you are the second, you need to calculate the height of those two. So it needs only those two. If you are the third, you need to calculate the height of the tree there. So what it does, it's not exactly that. It removes itself. So it needs this point. If it's the second one, it needs to know this height. So it takes only this mesh. If it's the third, it takes only those two mesh and take their height together to get the Z height, and so on and so on. So what I did is that I spread them each, gave them all of the mesh. If I sample only this one, I gave them all the mesh. Every story has all the mesh, and then I remove here max loop index. I gave them a loop index name here, so area would skip the 0 and the rest will go in. If we look at in here, it gives 1, 2, 3, 4, 5 without the 0, and it's just for the loop index. Because when you do that and you put this, those are not index. Index are inside of those. Those are, I think it's their name would be loop. But when you have those little bugs in a folder like that and you send them in a loop, it will name loop index at the end. It will rename them the loop index. And if I look at in the end, you see it's 2 now. And if I look at the third, and the 0 has been cut out. In loop index 1, you see 0 does not exist. It goes up to 4. So this is made by them. It renamed them. It always does. Except if I'm mistaken, but I don't think, because sometimes you can rename the copy an attribute, but that's not what's happening there. It really creates this attribute loop index, and what I do is I call it. Since I know that loop index is now in there, I can put this here. So it takes the loop index, I keep the name in the output, so it shows there, and it can be recalled later on if I want, because I put it back in the output. Oh, I think it would still stick there even though I don't. I could give it another name if I want and call it with the other name later on. So I pick the max, which what it does to pick the max, not much. If I pick another one, it is still the same, because there is only a max in each of them. If I go now, I see what is outputted there. If I see what is inputted here, the loop index is cat. There is nothing else than 4, so I can put anything in there. It won't change anything. What it does for me, why do I need it? Why can't I do like point to data to attribute? I don't know. I don't remember having tested this, but I guess that I can't. To that point. No. Point to attribute. Yes. Why can't I do this? Let's see. Oh, it worked. So I can get rid of it. Just needed this. Maybe I was trying something else at that time, but I need the loop. That's for sure. Okay, so what I did is the important thing here is inside. I say give me from this loop index, give me what is smaller than the loop index. So it will remove the, when I'm like at the second one, it won't calculate the height. It will jump the itself. That's what is smaller than 2. So because it's smaller than its own index, its own story. Give me only things that are smaller than your own story, except the 0, because the 0 is already skipped in the input here. So that's what it does. It skipped the current height of a current story. It calculates only what is between itself and the first, not the 0. So as we can see, the visual understanding of this is you look at the input, and this is all it's what is in there, what's coming in with all the meshes for each. This is the last one, the 4 top, the little small ear, the tall, and small at the row here. And what's in the filter coming in? It's the index. It's give the 0. It's right at the loop index 1, 2, 3, and here when it gets this, let's say it's at 2, it check 2 smaller than 2. Index would take the index that is in here. So it will compare the index here with the index in the filter here. So the operator would be 2 here at this one, at this loop. Those are the loops. So when we are at this loop, it says 2. Give me what is smaller than 2. So yeah, give me what is smaller than 2. I'm trying to find the order of. So 2 would be on this side. Yeah. And then it will check what is smaller than 2 from the input. Because it's not an operator like a 2 smaller. Okay, at first I was like, maybe I want both like, equal and smaller, but it did this, and it took me some time. I reflected, and I was like, why do I have a gap? And then when I followed from here, I thought, why smaller and equal? I don't want my current story. And then this solved it. So this index smaller. What is everything that is smaller than this index? That's what how you can read this. Everything that is smaller than this. No, not this index. Everything that is smaller than this loop index from the index that will show in here. That's how you read it. Because I get 2 here if I'm on this loop. And the index here will compare it to anything that is in here. If you want it to compare with the position, you would put position here, and it would compare with dot x. It would compare everything with this column, and so on with the other values. And then it output anything that is under loop index from the list of index there. From that, it output here those that are smaller than the current index, not the current index, and not 0. And it's what the F is that? Why do I get? So I separate them into why I don't think I might not need this. Just take it to this. No, I really need it. I just need to remember why. Because when you do this, you are like very logical. You have to be very logical. So you do it. The first step work, and you go to the second step, and then the second step work. You go to third step, and then eventually you do so much step that you forget what you did. You cannot hold all this information at once. Let's see, why do I get the index here? I might separate something. This attribute partition, it partition something. It separates something into pieces. So the output should be separated and the input should not. But that's not what is happening. That's not what is happening. I think it's creating it. So the feedback, I think it helps to separate before loop. Often you will see an attribute partition to separate things into pieces, into loops, and it doesn't show in here. It won't show in here, except there. Won't show up at all, but it will show up here. And then put here. And I think that's because it creates loop index, but I'm not sure. See that. Yeah. As you can see, they have all the meshes below them here. And it's skip again the it's subtract, so it's subtract the current loop again, which might not be needed, but it seems to work. Yeah, I think I needed this because it's an attribute. It's not the blue one, so I needed to redo the calling the current again. And the loop. The thing is, what where I was blocked on the previous episode is to get the feedback working, and to get it working, one of the solution was to I think it was the attribute partition, because it wasn't the feedback wasn't adding up to each other because it lacked the many objects, and the partition helped in that. So maybe I may be wrong. Let's see if my hypothesis is still this. So as you can see, it add up here on the output. It adds up all of them together, all the heights, and you see it's growing up to 849 for this one, and the last one, the little roof up, same thing. And I think yeah, that's that. So this is small, tall plus tall plus tall plus small, and there we go. So if I remove partition there, like I did minutes ago, let's see if it stopped adding up. Let's see if it's adding up. As you can see, it's the mesh aren't there. There's only one, and it's not adding up. So it really helps to spread your loop. That was the solution for me for getting the feedback loop to work. Finally, it was not easy. And the current loop, I didn't. Oh, damn. Sammy Boo is back. But now I can see that Damn. Because I wasn't there for 3 days or something. Maybe I would have been able to maybe I could have do a distraction and you would miss. I couldn't do it. I felt like if I do it too much, I started hating my project. So I needed this break. I needed it. So it's in that current loop index might not be necessary there. Is it? Let's see. Yeah, but this one I did yesterday, so it's just that I finally got to. Yeah, no, I know that I've been in the management hell. I've been in there with the Jira and anything else like that. I like it, but I needed to stop doing it. Stop doing tasks. Now I use Trello from time to time when I feel like it. It's a bit devastated. How do I say? The list is still there, but my tasks are seems to be correct. But I'm a big project management tool fanboy. But I needed not a break. When you do drugs, a withdrawal. But Trello is fine. Like it's like if you do Jira, there's a level of drug strength with the project management tools. When you do it on paper, is like the lowest drug intensity. Next, you do it on Trello, it's a bit higher. The drug is a bit higher. Next one you do on GitHub project, the drug is a bit higher, and then you do it on Ensoft or Jira, and then the drug is like over the top. It's like cocaine. And oops, I think I shouldn't say words like that on on YouTube. I will get yeah, I shouldn't say words like that. Forget about this word. You never heard it. Those are not the droids you are looking for. You're not helping. You're not helping. You're not helping. You're not helping. Okay. Now. I was explaining something to anyone who will search for PCG loops and all the trouble I've had for the past 4 episodes. So as you can see, when you make a damn it, but I think I get the gist of it. I get them the gist of it. They just need to, when they do feedback loop, they just might need the attribute partition to spread the loops wide. Spread the cheeks wide. So yes. Oh no. Oh no. I don't advise. I don't advise this at all. Not. It's specific for specific people. Like if you want to do procedural modeling, not really for other reasons. Well, it's just coding with table management. Anything that's node-based like that, it's coding with. But you can do it like you take create attribute and then you put the boolean there. Create attribute boolean. What else? I think that's it. Now it bring the height of every story there, and that's it. Everyone is happy, and it continue, and it's there. It's all done. Do I go back to the character now before it's too late? You did a thing. What thing did you do? Sammy Booth. I was done maybe with the PCG episode and go back to the character episode, but I would need to restart the stream with a new name. And it's 10 p.m. Yeah. What do you say about that? What do you catch me on the other? I have at least one. Yeah, one or two, but yeah. Do you want to switch to characters with me? I will be back. So it means that I need to shut down this this stream and open a new one. Yo, debugger go. The debugger goes. Debugger goes. Meme. Meme. I'm guessing that someone did a meme like that. Printf go. What? I always print, but the PCG don't have print. Like shaders, they don't have print. Shaders, you You debug by printing out the color. Yeah, shaders act on each pixel, so the only way to debug is to print a color on the pixel. A specific color. Yeah, that would be hard. I want the debugger goes. Debugging is now complete. What is that? What is that? I don't understand what is that. This. What is this? You saw. You know. What is that language? Plus language? Plus language? Damn it. Plus language? Oh, plus language. Okay. I thought it was a language called plus language. Like that? Is it bitwise bit shift or something? Bitwise operator. Oh, okay, it's bitwise operator. You just shift the bit. Yes. You shift the bits. I learned this at school. Yeah. I remember this. Won't ever. I don't know if I will ever use it. But it's good to know. Oh. Discord. Not open up. Fireship.
Brainfuck, a minimal esoteric
I know
programming
this
language
channel.
designed to make your brain hurt. It's Turing complete, but not designed to build actual software. It's more like a work of art that challenges the status quo. It was created in 1993 by Swiss physics student Urban Müller, where the goal was to create a language with the smallest possible compiler. It was built for the Amiga 2.0 operating system, and the compiler weighs in at under 200 bytes. A Brainfuck program starts with a 30,000 byte one-dimensional array. All values are initialized to 0, then it provides a movable pointer that you can manipulate with 8 different commands. Use angle brackets to move the pointer left or right by one cell at a time, then increment or decrement the value in a cell using plus or minus. Use a period to output the byte at the pointer's current location, or use a comma to accept input and store it at the pointer's current location. And finally, use opening and closing brackets to create a loop. Notice how Brainfuck doesn't require silly things like variables, functions, and classes. To get started with Brainfuck, delete your operating system and install Amiga OS. Then create a file ending in .bf, which stands for Brainfuck. Any characters that are not the 8 I mentioned previously will be ignored as a comment. At this point, we have an array with 30,000 8-bit numbers, all set to 0. To say hi mom, we'll need to set each number to its corresponding ASCII character. We can increment the first cell, then enter a loop with an opening bracket. For each iteration of the loop, we'll decrement the current cell by 5, then then use an angle bracket to move one cell to the right. We'll increment that cell by 3, then move back to the left and close the loop. The loop will continue until the original cell goes back to 0, at which point it will exit. We now have a value of 103 at index 1. We can move the pointer to it, increment it to 104, then use a period to output it. That corresponds to the letter H in ASCII. We can increment it again to get 105, which corresponds to the letter I. Now we continue this process of manipulating memory like cavemen until we output all the characters that we need. Now to run your code, use right-click, copy, and paste it into one of the many online interpreters. Congratulations, you just said hi to your mom in Brainfuck. This has been Brainfuck in 100 seconds. If you want to see more Brainfuck content on this channel,
I didn't know
make sure
about
to hit
that.
the like button and subscribe. Thanks for watching.
Reminds me of this, the language, the machine language, the dumb, I have a blank. Move, etc. Language. I have a blank. Where's my memory? I'm sure we talked about this the first time we met. In Redstone, probably. I have a blank. Assembly. Yeah, it reminds me of assembly. You do this similar thing. It's similar to this. What else? How do we call the another blank? But I cannot leave blank memory like that. I need to find. I need to find what I'm looking for. It's not a language in itself, but it's a syntax, which you will find in what is the name? Not Lua. Where's the language? What is the name? I don't like having a blank memory. A memory fart. Damn it. I need it sure is I have this in my bookmark somewhere. But find this. Let's see if I can. I hate having a memory blank so much that I will take the time to find it. Source control. Oh, I found it. It reminds me of regular expressions. I wonder if the same guy did. Yes,
Yesterday, one of the most scandalous lawsuits.
Let's see if he did a video on regex. Oh yes.
Regular expressions, aka regex or regex if you prefer, is a tool for finding patterns within a string. Its two most common use cases include the validation of user-generated input and to search through a large body of text, such as a find and replace operation in a document. It's notoriously difficult to learn because its syntax ends up looking like a meaningless pile of gibberish. But once you learn it, you'll have a very powerful and universal way to parse text in any programming language. For example, in JavaScript, you can use match to find all the matching patterns within a string, search to test for a single match, and replace to replace the matching patterns. But before you can put these to use, you need to know how to write a regular expression. In JS, we can do that with the literal syntax by starting with 2 forward slashes. Between these characters is where we define our search pattern. You can find an exact match by simply typing the string you're looking for. By default, it will only find the first match. However, you can change this behavior by adding a flag to the right side of the closing slash. The G flag means global, and will look for multiple matches in the text. And you can add additional flags here as well. Now, in order to create a more complex search pattern, you combine a handful of special characters within your expression. Use a vertical bar as a logical OR to match one string or the other. You can group your logic using parentheses. This isolates your code from the rest of the pattern so you can capture substrings. You can use quantifiers to control how often the preceding pattern is allowed to occur. A question mark allows a pattern to occur 0 or 1 times. An asterisk allows a pattern to occur 0 or multiple times, and a plus sign means 1 or more times. Or you can control this behavior explicitly using braces, setting an exact number of occurrences or a min-max value. You can use a backslash in your pattern to escape any of these special characters, or a backslash might refer to a character class, like D for any digit, or W for any word character. Make these a capital letter, and now you have anything that's not a digit or not a word character. You can use brackets to define your own custom character sets, like a range of all capital letters from A to Z, or a custom character set that you create. And you can negate the set by adding a caret in front of it. But like I said at the beginning, regex is not an easy thing to learn. Check out my cheat sheet on Fireship.io for a bunch of common examples that I find useful.
Let's check what he says about assembly.
Assembly, a low-level programming language designed to simplify the instructions fed into a computer's CPU. In other words, it's a human-readable abstraction on top of machine code, so programmers don't have to manually count ones and zeros. The first assembly language was created by Kathleen Booth in 1947 for the all-purpose electronic computer. Over the next decade, it evolved into many different formats to power the supercomputers of the day, like the IBM 7090, which had a $20 million price tag in today's dollars. Writing code in assembly was standard until the emergence of high-level languages like Fortran a few years later. However, assembly is still used today for direct access to the bare metal hardware and to address low-level performance issues, often on device drivers and embedded systems, and it's also used to run native software in a web browser via WebAssembly. What's tricky is that each assembly language only works on a specific CPU architecture, like ARM for Apple Silicon and Raspberry Pi, or x86 for Intel chips. To get started, you'll first need an assembler, like the NetWide assembler for x86 chips. An assembly program is divided into 3 sections. The text section contains the actual logic for the program. By convention, it contains an entry point called start, which is where the code will start executing. Next, we have the block starting symbol section, which contains variables that might change throughout the lifecycle of the app. And finally, the data section is where we can initialize constants, or data that does not change. To declare a constant like a string, we start with a label, then use db for defined byte to place the hello world string into memory. By itself, it doesn't do anything, and to print it to the standard output, we will also need its length. length. We can use equate to convert a symbol into a constant. The $sign will subtract the current position from the hello label, providing the length of the string. And now these constants can be referenced from the start label. In the main program, each line of code contains an instruction along with one or more operands, and there are hundreds of instructions built into the language. Now, to perform operations quickly, the CPU has a limited number of registers, which are like 64-bit chunks of memory built directly into the CPU instead of the RAM. We can insert data into a register with the move instruction by providing operands for the register name and the data to store there. In this case, number 1 is used because it corresponds to system write on Linux. Next, we need to tell the system where to write, in which case we'll move 1 into the RDI register, which corresponds to the standard output in the terminal. The next register stores the message to write along with its length. Now execute the code stored in the CPU by calling the operating system kernel. Almost done, but we'll get a segmentation fault if we try to run it at this point. Update the RAX register with 60 for system exit and provide an error code of 0 for success. Now use the assembler to compile or assemble your code into an object file, then use the linker to convert it into the final executable. This has been assembly language in 100 seconds. If you want to see more short videos like this, hit
Damn. Okay. Am I done for tonight? My. What? What is a TTS? What do you mean? Am I done for today? I'm not sure. I don't want to be, but I'm really tired. Yeah, I'm really tired. I don't want to be. When is your next version? Hmm. Ay. I should move to a drawing. That's it's less intensive. So, will you be back in a few minutes in the next stream? Okay, so let's roll the outro then.